Welcome everybody to the last session of Baltimore Data Week, day 3. We still have a whole other day tomorrow, so hopefully you'll join us there tomorrow. My name is Seema Iyer, and I oversee the Baltimore Neighborhood Indicators Alliance at the University of Baltimore. And today, this afternoon, is a real treat. We're going to be catching up with some of our own students and the work that they've been doing with their host organizations. And you're going to learn more about that. But I want to kind of explain why we even have data science students. And for those that have been with us at Data Day for the last couple of years, we were lucky enough to get a, hopefully we're looking at our website. We were lucky enough to get a grant from the National Science Foundation just in March of 2020. We are working in combination with 4 different institutions, with UMBC, Bowie State, Towson, and here at UB, on trying to come up with a common curriculum for data science students to learn how to use their skills for an applied nature to help urban areas like Baltimore. So our Data Science Corps to improve quality of life in urban areas is a project. I will put this link in the chat. We have now had several different cohorts. This is our summer 2022 session. Bozkurt, Charles, and Jonathan are going to be talking about what they've learned so far in the summer. But we just hired Paredes, who used to be a data science student at Towson, one of our kind of colleagues up at Towson. And he, when he was there, actually worked on a project with us at the Baltimore Neighborhood Indicators Alliance. So I feel like it's a good feeder program. We can hire right within the Data Science Corps. I will say that other people have hired our data science students. If you are looking for data science students, we have a great crop of students that not only have the technical skills, but they understand why they're doing what they're doing. And that's our main goal, is to make sure that they understand how their data science skills can help address urban issues like those here in Baltimore. This website has lots of information about prior cohorts. Some of you have been mentors to our data science students in the past, and you can see their projects. And this repository of projects is meant to help us learn about common things that we all have with respect to data science. We're going to start off with Germán Paredes, who is our developer now at the Baltimore Neighborhood Indicators Alliance, just started in April. And since April, he's been working on an amazing project to help everybody calculate our vital signs indicators. And so I'm going to turn it over to you, Germán.
Sounds good. Thank you, Seema. Let me share my screen here. Okay, can everybody see that right now?
Yep.
Okay, cool. So good afternoon, everybody. My name is Germán Paredes. As Seema mentioned, I've been the developer for BINIA since April of this year. And today I'm just going to be giving you a demonstration of how to use the vital signs indicator scripts that I have developed for BINIA's yearly vital signs report. So I'm going to open my chat here on the side. So as you can see here, I'm in the GitHub account for BINIA, which I'll give you the link here on the chat. And I'm just going to scroll down a little bit, and here is our vital signs repository. If we click here, it's going to bring us to vital signs. And I'm not going to go over the explanation here as it's only describing what vital signs is about and what the scripts are supposed to be doing. So I'm just going to skip this for now. However, but the vital signs scripts are written in 2 different versions. The main one being Jupyter notebooks, even though I'm using Python to write them. And then we have a regular Python file. So the reason being for Jupyter notebooks is because anyone who has access to Google Docs can pretty much create a Jupyter notebook from Google Colab. As such, if you look at this option right here on this line, the very first one says open in Colab. If we click on this, it will open basically the README file from the repo in Google Colab, but you can run the code right away. So you can think of this as a kind of pre-made document to just read and run everything as you're going along. For this demonstration, however, I'm gonna skip over how to install things up here, and I'm just gonna go right to the examples here. So for the Battle Science library, as of right now, there are 46 different scripts in total to get all the Battle Science indicators. And 45 out of those 46 scripts are gonna use the process shown in example number 1. You wanna use the same process for basically every single script with all the tables that we use, except one of them. That different one, I'll go over during example 2. So to get started with the demonstration here, I'm just gonna be copying and pasting everything that is in here in a fresh Jupyter Notebook file that I have open here. So I'm gonna copy and paste the first one, which for those of you who have worked with Python before or any programming language in general, we are just installing the Battle Science library along with our data play library and GeoPandas. So I'm just gonna run this cell. I had it installed already just in case. So, but you can see that it's already installed here with Battle Science library. And here you can see the version number of the library itself as well. I'm gonna create a new cell. I'm gonna come to the next one. So what we are doing here is just importing our retrieve ACS data function, which is basically the function that is going to help us get our raw data from the US Census website. Basically, we're just accessing their API to pull the raw data. So I'm going to run this. I'm going to come back again. Then I'm going to copy these 5 variables right here. So what these 5 variables are doing, these go within the API link to pull the data. So we have all the track numbers. That's why we have an asterisk here. We have county equal to 510, which will be Baltimore City, and state 24, which is just the numerical value for Maryland. These ones, you don't really need to touch them or anything at all, as they are just defaults. However, the 2 important ones are these 2. We have the table ID, which is basically what table of data do we want to pull data from, and then the year, which is pretty self-explanatory. What year of data do we want? In this case, I'm going to keep this table that is right here, but I'm going to change the year to 20. However, obviously, we don't expect anyone to know, what table IDs are about or what table means what. So if we come back here to the repo, I'm going to scroll all the way back up here. And then we look at this 4th document right here, ACS tables and scripts. If I open this file, this is basically a little cheat sheet that I made where you can look at all the individual table IDs, the scripts that go along with that table, and the indicators output that you're going to be getting by using each individual script right here. So this is something that you can kind of keep on your second screen or just something on the side, so you can just be matching things up with the table ID that you want and any of the scripts that you need. So now that we run our 5 variables here, I'm going to come back to the code, scroll back down, and now we want to import our raw data. I'm going to copy paste this. I'm going to change this to 5. You can see we are using the function that we imported up here, and then our 4 variables right here. So I'm going to run this. The time this is going to take for you to get this raw data is really going to depend on the table that we are using. Some of the tables are pretty big. They have about like 45 plus individual columns worth of data. So those could take about 5 to 10 seconds each of data, or of time, excuse me, to pull it in here. Now that we have this table right here, we can see on the left side, we have all the individual census tract numbers. And if we want to make sure that we have the correct table that we're looking for, if we go back to the little cheat sheet here, we can see that this table is basically population and age, right? To be specific, the name of this table is sex by age. So males in the specific age range, and then females and their age range. So if we want to make sure that we have the right data here, we can just look at the columns on the table here. We have, for example, males under 5 years old, 5 to 9, and so on. And if we go more to the right, we can see we get to females 50 to 54, 55 to 59, etc. So now we know that we have the correct table. We're done with getting the raw data. I'm going to make a new cell. I'm going to skip this for now. And now that we have the raw data, we want, well, the actual important stuff here, right? Which is, how does this data relate to the indicators within Baltimore City? As such, we are going to import our first script here. So you can see we have, from the Vital Signs library, we want to create an indicator, and this is the one that we want specifically. Going back to our cheat sheet again, we can see that table 01001 uses this script. But let's say that we want to use another one as well. We can simply grab this line of code. I'm going to copy it. I'll paste it again. And let's say that we want age 65 to get this indicator. So I'm just going to put 6 in there, and that's all you have to do. This bit of code is always going to be the same, no matter what script you want to use. You just copy and paste it, and you just change this last bit at the end. So I'm going to run this, and that's all we have to do. I'm going to come back here, and this is the biggest chunk of code that we're going to be using for this entire thing. I'm going to paste it here, and all of that this is doing is, we have our merging table with our indicator's name, or a crosswalk, if you will. Then we have the left column, or the column from the raw data that we're going to be using to merge both tables. Then we have the right column name, which comes from our crosswalk table, and the type of merge that we want to use. In this case, we want to merge everything, so we're using an outer merge. And then what CSA names do we want to use? Since now we have the 2020 CSA name available, we can kind of get to choose now if we want to use the 20 tag names or the 2020 names. However, since we are getting the 2020 data, I'm going to change this to 2020. And then we have this other variable here, which is the method. Basically, all that this means is, what script do you want to use for this table? So up here, we imported H5 and H65. So I'm just going to put this in here. We want to use the script H65. We can ignore this. We can ignore this as well. And now we have our create this indicator function with everything that we just defined already. You can see we have the state, county, track, and year and tables, which we defined up here. And then we have everything else that we just defined up here. So I'm going to get the first thing here. I'm just going to run this. Now, before I get to the table, you can kind of verify the process of everything right here. You can see what table we are pulling data from. You can see the year that we are importing. Here is our merging table. And then this is just a little description of how the process is going. Now we come down here to the table. You can see on the left side, we have the CSA 2020 names. We have the grand total population in here. And now, since we are using the H65 script, which is going to give us the percent of population 65 years and over, we can verify by simply reading at the columns that are available in this table. So you can see that the very first one is male 65 to 66, 67, 69, and so on. And if we go a bit to the right, we can see they have female 65, 66, 67, 69, and so on. And if we go all the way to the right, we have our percentages right here. So here you can see that we have 14.34% of the population in Allendale are 65 years and over on percentage-wise. So this is pretty much how we get our indicators names and their percentages. I'm going to close this for now. I'm going to make a new cell. So now that we have our indicators, the big question is, how do we save them, right? So I'm going to come back to the repo, and I'm just going to copy paste this code right here. I'm going to paste it here, and I'm going to comment this out for now. So all of that this code is doing is If we look at here on the left side of the screen, you see this little folder over here, and I'm going to click on it. And that's going to open my files directory for this specific instance of Google Colab that I have open. So what this is doing is basically, this is letting me pretty much access this files folder on the left. And what this line of code is doing is that I am grabbing my indicators, which I define up here, meaning my table. I want to save it as a CSV file, and I want to give it this name. That's all this is doing. So if I run this code, nothing happens. Well, let's refresh this column on the left side here. So I'm going to click on the folder again and reopen it, and there is our file. So now we have it saved locally in this instance of Google Colab, not necessarily on my machine right now. So I'm going to get this code back. And what this line of code is doing, it's basically saying, from my files here on the left, download these files specifically. So it's going to look into these files on the left. Once it finds the name, it's going to download it to my machine. So I'm going to run this again. I'm going to save it. I'm going to open it. I don't know if you can see it right now, but you should be seeing a CSV file.
Yep.
Can you see it? Okay, cool. So you can see this is the exact same table that we just saw from the output. We have our 2020 indicators names. You can see that we have male 65, 65, and so on, female 65, 66. And here are our percentages. And that's how we save our tables locally. Now, again, if you recall, this is the process that you want to follow for 54 out of the 55 scripts, or 45 out of the 46 scripts. Now, for the only one that is different, I'm going to go over again. For the most part, it's the same. You can see that we start with installing the Vital Signs library. We import our function. We define our variables here, but we are going to be using a different table this time. So I'm going to copy and paste this table ID. I'm going to paste it there. I'm going to run this code, and everything else is remaining the same. Same track, same county, same state, same year. All I'm replacing is this table ID right here. I'm going to make a new cell. We want to import our raw data again. I'm going to run this. Now, if we look at the column names, we can already tell that this is a completely different table. This is population of white alone, Black or African American, American Indian, Asian alone, etc. Reason being, if I go to my cheat sheet here, this is the table that we are using. This is going to be our racial diversity index table. So we have our racial data up here. I'm going to close this. I'm going to make a new cell. And now we're going to follow, again, the exact same process as before. We're just going to import our script. I'm going to run it. Copy all of this code again. Let's get the first thing here. And here is where the one and only difference between this script and everything else comes in. I'm going to run this code. Oh, let me put 20 here. And nothing happens. But if we look at this output so far, we have the table ID, the year, our merging table, just like before, and all of this processing, exact same thing as before. However, for this script, we have this extra step right here, which is just asking you to re-enter the year for the data. In our case, we were using year 20. I'm just going to put 20 here. I'm going to hit enter. And now we have our table. The reason this script is different compared to everything else is if we look at this code again, you can see that I input 20 again, but now look at this line of code right here. Table 03002, year 20. This table is completely different from this table. And the reason is that in the US Census data, when it comes to racial data, it is divided into two individual tables. We have the Hispanic data alone table, and then everything else table. So this table includes all the races put together in one table, and table 03002 is the Hispanic only table, which means that this script, this reactive script, is the only script in all of Vital Signs that relies in two tables at the same time. And the reason we are importing or inputting this year again is since we have both 2010 CSAs and 2020 CSA names, this year is used to determine what names are we going to use. Meaning, if the number is less than 20, we're going to be using the 2010 CSAs. If it's 20 or higher, we're going to be using the 2020 CSAs. That's basically the only reason. And if we come back here to our table, you can see that we have our 2020 CSAs again. And we have our percentages of each population, white percentage, African American, American Indian, etc. And at the very end, we have our racial diversity indicator. And if we want to save this table, we do the exact same thing as before, where we can just copy and paste this thing again. You can see this is the exact same thing as before. Saving it as a CSV, we're giving it a name, and then we just download it again. I'm gonna save it, gonna open it here. And you can see we have our 2020 CSAs, white percentage, African American, etc., and then our racial diversity index indicator at the end locally. So that's pretty much how you use all the scripts for Vital Signs. Again, if you are not like 100% sure how to match up table IDs with the scripts, you can just follow along the little cheat sheet right here. Now, in terms of the demonstration, that's pretty much it. But for those of you that want to take a look at like how things are actually running in the background, how the functions were made and everything, I'm just going to show you really quick how to access the code itself. So as I mentioned at the beginning, there are two different file formats that we are using. We have a Jupyter notebooks, and then we have a normal Python file. As such, if you want to access the Python file, all you have to do is click on this Vital Signs folder, and then you want to check this create.py file. If I open it here, it's going to open a regular Python document. I'm going to scroll down a little bit, and you can see here are our functions already. We have H5, H18, H24. If I scroll down a little bit more, H65, the one that we just used. In order to kind of make it easy to like scroll through all of this because it's a lot, they were written in the exact same order that you can see in here. So the order that you see the scripts in here is the exact same order than the code is written as, just for simplicity's sake. Now, to access the Jupyter notebook of this code, I'm going to go back here, but we want to click in the notebooks folder. And then we want to go to this fourth one right here, create ACS indicators.jupyter. We open this, basically exact same code, exact same order, is just a different format of all of this. Scroll down a little bit, and here is our code, H5, 18, 24, and here's our H65. And yeah, that's pretty much it. That's the whole thing for Vital Signs.
Oh my God, Arman, that was awesome. Everybody is like doing the happy dance in the background. Excellent job doing that live demonstration. Really amazing work. And I want to thank Professor Mike McGuire at Towson for teaching him everything that he knows and sending him to us. So thanks for being on the call too, Mike. All right, so hopefully all of you will give it a shot and make your own indicators. Dexter, the question of margins of error, we don't download the error because you have to aggregate the error by the census tract into the CSA, and that's a different calculation, which we just don't do. aggregating the error to the tract. But maybe that's our next step, is to download and aggregate the error to the CSAs too. So I want to turn it over to this summer's mentors. Thanks again, Armand.
Sure.
We're going to start off with John Cleary, right? We decided John was going to go first. He is one of our current summertime students, and want to thank Justin Alsace, the Chief Data Officer for the City of Baltimore, for serving as his mentor this summer. And I'll turn it over to you, John.
All righty. Let's share my screen. All righty. Can everyone see this?
Yes.
Yep.
All right, cool. Hello, everyone. My name is John Cleary. My project this summer is a dashboard, which is, of course, a setup of charts and other visuals meant to show data on our particular topic. And as mentioned, my mentor this summer has been Justin Alsace, the Chief Data Officer with the City of Baltimore. Now, the purpose of this project has been gathering information on 311 service requests, towing data, and environmental citations, and bringing them together and giving a snapshot of what's going on in the city. Reason being, these three areas have been, ongoing challenges, particularly since COVID has been hitting, particularly with the shortages of people sometimes. And so this dashboard is meant to show trends for the city leaders about what's going on, and so they can deploy resources more efficiently and effectively. So the dashboard was not just meant to be a generic search tool. It was meant to show relevant trends up front, rather than making the readers have to wade through information to try to find what they're looking for. Now, the data came from Open Baltimore, which is a free service of data on the city's website. And then, as I mentioned, the data came from Open Baltimore. It was taken from the past 2 years. And the program that I used to create this dashboard, which we'll see shortly, is Power BI. It's a Microsoft program that's meant for displaying data visually to try and, again, gain information about certain topics. Now, some technical issues that were encountered on this project was, of course, I had to learn Power BI from scratch. And so there were many hours of YouTube tutorials and other readings that I had to go into to learn about the program. It was actually not too hard to catch up on some of the basics, but of course, this program has many nuances, and so there's always learning to be done. Now, another technical issue that I encountered was getting dynamic data as opposed to static data. So at the moment, the data we have is simply downloaded from Open Baltimore. It doesn't refresh itself, but we're working on getting data which will update itself so we can keep the information relevant and current. And then, of course, with all projects like these, we had to wrangle the data to fit it into visuals properly that we wanted to use. And so some of this was done with trial and error, and some of it was done by watching more tutorials. So progress we've made so far this summer, we so far have 11 different working visuals for the three areas we're looking at. Again, the towing, environmental citations, and 311 service requests. We have buttons and slicers which can show the data in different timescales and areas. In this case, we chose to show data for the last 7, 28, 90, 180 days, or 1 or 2 years. And you can also see the data by city council district. And fortunately, and probably most importantly, we were able to format most of the data into the proper type so that we could get it into the visuals, and this included editing it, eliminating unnecessary parts, et cetera, et cetera. And so this right here is what we have so far for our dashboard. As you can see in the main body here, there are 12, or there will be 12 different visuals that are used when the dashboard is done. They're divided into 3 areas: the environmental citations, service requests, and towing data. And at the top here, you can see the buttons and the slicers, which can divide the data up into different time periods or by city council district. So of course, we're not finished yet. We still need to get some of this dynamic data, which will update itself, and we'll have to be installing an API in order to connect the live data to the dashboard so that the data can remain fresh and current and keep the information relevant. And if you notice, there was one visual that wasn't complete. There was a towing by council district, which we're trying to wrangle data into, which still needs to be done. And then just we're going to overlook certain aspects of the look of the visuals, like the font sizes, the spacing. And this is mostly going to be done so that we can keep it similar to other reports or dashboards done by the city. And so what I learned along the way, or what I've learned so far, is that data science is its own deep field. I happen to be studying environmental science in school, but data science is just like it. It has its own discourse community with its own unique lingo, tools, etc. And from what I've gathered, there seem to be 4 major areas of data management, which are the gathering, cleaning, displaying, and the sharing of data. And of course, I learned all about the Power BI applications. Many of the basics came relatively simple. A lot of it is just drag and drop. And then some of the specifics, like how to manipulate the data to get certain visuals to work, were also learned as well. And above pretty much everything else, I learned that clean data makes things work. You have to keep things organized, edited, formatted, etc., in order for your visuals and your data to show up properly, so they don't give you any weird trends or anything like that. And so at the bottom here, I have a screenshot of some of our data from the Power BI application. And that's all. Thank you.
Great job, Jonathan. And thanks so much, Justin, for helping him get to this point so far. And we look forward to seeing the final product in August. I'm going to turn it over to Charles and Bozkurt, and I want to thank Sergeant Miller and Graham Campbell for being here, Sergeant Miles, sorry, and Graham Campbell for being here from the police department and serving as their mentor this summer. I think Charles is going to start, right?
Yep, thank you. Hello, my name is Charles Lack. I am a senior at the University of Baltimore. I am studying health systems management, and I am working with Bozkurt.
Hi, my name is Bozkurt. I'm a senior IT major. I will be talking about the visualization part of the project.
Yeah. We will be talking about our Data Science Corps Summer 2022 project with the Baltimore Police Department. We were tasked to create a Tableau dashboard that details arrest debriefs. The process of an arrest debriefing goes like this. Someone calls the police, a police officer arrives on the scene, and if there is an arrest, there is a voluntary arrest debrief questioning. The BPD's goal for documented debriefing with an arrest is because it is an effective information collection method to identify suspects responsible for serious criminal activity. This slide includes the debriefing form that is the root cause or the root of our data. It is a bit hard to see, but the questions include: who do you know that steals cars, and what colors, clothing, or marks do the gangs wear? These questions are meant to find information about other people. It is because an arrest debriefing is not meant to elicit an incriminating response. Additionally, it is vital to know that an arrest debriefing is completely voluntary. The police officer is not forcing the suspect to answer these questions. After the debriefing information has been gathered, what gets sent into our Excel datasheet is where and if a debriefing has occurred. Our datasheet contains a Boolean value that depicts whether a debriefing has occurred. So we are now working with the actual questions from before. So BPD's executive command wants 100% of arrests to be debriefed. The goal of our dashboard is to show the change over time with the amount of debriefs being done. We will go into which districts in Baltimore are doing the most debriefings. Our data set came from an Excel sheet that contained 16 variables, 6,816 observations. There were 12 text type variables, 2 data type, 1 integer type, and 1 Boolean type. This data is classified, and Bozkurt and I had to sign a confidentiality contract before seeing the data set. Naturally, with such a large data set, we ran into some problems. These problems include too much information in one cell, no values, and irrelevant information blended with relevant data. For example, we had a column that contained repeating information with other columns. In this case, we used OpenRefine, an open source application for data cleanup and transformation. We used it to check if the information in the column is actually repeating or if there were unique values. Another example of an issue we encountered was that there were 3 columns that depicted districts. However, there were different amounts of variables in each of the 3 columns. We used OpenRefine and ran an Excel frequency count to test the difference between the 3 columns. Ultimately, the host organization chose the district column they wanted to see. However, that meant losing about 13% of the total data. And now I'll pass it over to Bozkurt to go into further depth.
Thank you. Let me share my screen. Okay, just a second. For our visualization, we use Tableau. Tableau is a visual analytics platform with drag and drop interface. We did not have a choice in using Tableau. That's what Baltimore Police Department uses for their dashboards. The project has been a learning experience for both Charles and I because neither of us had any prior experience with Tableau. The learning curve for Tableau is relatively short, but it has its own vocabulary to master, calculated fields, parameters. These are product-specific terminology. Best thing about Tableau is that once the data set is clean and ready for analysis, it chooses and generates the charts for the chosen variables. Although using Tableau does not require any prior coding skills, one can incorporate SQL structured query language or R statistical programming language. Here's an example of really repetitive and simple SQL code query we use to extract and isolate the information we needed from our data set. Our approach to debriefing, in deciding how to approach this visualization, we focused on the type of information the executive command needed. We are aware that the type of information executive command needs is functionally different than the officers on the street. The executive command oversees the entire department, thinks in terms of the entire department. So we thought a bird's eye view chart should be the centerpiece of our dashboard. And we try to avoid clutter, which may distract the executive user. We took a reasonably minimalist approach to our visualization. The reasoning is that we believe visualization for public consumption demands more chart elements because the chart has to be self-explanatory. More data markers, more extra legend information. But in our case, our visualization is just for internal use only. So we try to make our centerpiece as simple as we could. But we did not sacrifice any details. We did hide our data labels and decided to interactively display the district names total debriefing counts, percentage of all successful and unsuccessful debriefings, and we decide to enable the user choose date criteria. The thinking, overall thinking, is we wanted the executive command officers to see the overall picture first, and we wanted that picture make an impact. And then from then on, if they decide to drill down by asking questions, all they had to do is just hover their mouse tip and click on the part of the chart they wanted to focus. Tableau's tooltip option enabled us to do that. So far, we prepared 14 sheets, but we're not going to use all of it. Most of these sheets will be hidden in the dashboard. We do not have the dashboard yet. We also provided a drill down by dynamic filtering. We wrote 2 calculated fields, and we prepared formulated 3 parameters. What's next? We want to link all sheets dynamically, either using calculated fields or SQL queries. We will be switching to a slider filter as requested by our host organization, and our filter criteria will be changed. We also want to link the dashboard to source data for automatic update. And along the way, we will be checking, we've been doing it. We're going to keep being in touch with our host organization for specific choices and preferences in building our charts. What have I learned? Well, as I said, I had no experience with Tableau, but importance of clean data. If the data is not clean, just don't bother, because data visualization tools can be misleading or if not useless without clean data. Also, knowing data type is important for proper visualization. And definitely domain expertise must guide the analytics and the visualization. No matter how good the chart looks, if the user is not benefiting, then there's no point to that visualization. And that concludes my presentation, and I want to thank you all.
Great job, Charles and Bozkurt. I don't know if Justin, Sergeant Miles, or Graham want to say anything. Hopefully this was a good experience as being a mentor. And again, they're not done yet. They still are going to complete what they said. And you have lots of people that on this call that have data science experience. So I know Dexter has done a lot of this work, and yeah, you guys all did a great job. Any final thoughts anybody wants to share with our data science students as they move forward for this summer? Otherwise, we do have our evaluation for you to fill out, if you could, about this session. And if anybody has, hopefully we'll see many of you tomorrow for our final day of Baltimore Data Day, in person here at the University of Baltimore, across the street at the library at the law school. And hope to see many of you there. The evaluation form just went in the chat. Hopefully you get a chance to fill that out before you leave. And otherwise, we will see you tomorrow. Thanks, everybody. Great job to all of our